right. Let's get into it. Where is my... let's get into it. Where is... Why can't I see the screen? Okay, there we go. All right, sweet. We're back for a nighttime stream. I had to take a break for a week from streaming. I was on solo parent duty for a week. Kind of cut into my time, but we're back now. And we're working on Glyphos, which you can check out an old VOD. Most of them have demos in them. One of these days I'm going to put a proper demo up on YouTube that I can just refer to, but I haven't done that yet. But I'm just going to jump into the refactoring that we're doing now because it's late and I want to get as much done as I can. Basically goal is to convert all of the SymbolNode trees into binary symbol nodes, binary symbol trees, which the hope is they will be faster. And where we got to was taking a look at this relabel all function from SymbolNode, which takes a relabeling, which is basically a map from one name of a node to another name of a node, and relabels everything everywhere. And it in turn uses this internal function relabel and get addresses if to do the relabeling. So we may need that to implement that as well. So let's take a look at how this works first. So we're folding ourselves. This seems really slow, is my first thought. So we're starting with a clone. So we're cloning ourselves, which could be big and deep, and an empty hash map. And so we're saying, okay, so we're cloning once, and we're saying the accumulator is our self. And then we get the new tree, and we get the addresses. And then we relabel and get addresses if. So the condition is, does the address contain so there's a set of addresses that we're accumulating. We say if addresses doesn't contain address, we return. Fine. Where is address coming from? Oh, it's a... Okay. So it's been a long time since I wrote this code. So relabeling get addresses if does what? Oops. Relabeling get addresses if takes a current address and a function and a condition that can be a function of the current address. Okay. This seems very slow and like the sort of thing that we're trying to optimize away. So let's optimize it away. Binary symbol tree. And where do we want to put it? Contain substituent with child replaced. Seems like sometime before there would be good. Okay. Relabeling still makes sense. We just return a self. What happens? Okay, we're not doing any checking on this at all, which we probably should. Maybe. Here's my problem. What if we relabel something like, I guess it's okay. Yeah, okay. I was worried we could have ambiguous types, but the only way we could have ambiguous types is if the type started out ambiguous, so I think we're fine. Okay. This should be really easy, actually, with binary symbol trees. Because all we should have to do is what? Self.nodes. I guess we're getting a new cell we're cloning here. It's like a slightly open question of like, do we really need to clone here? But I'm not gonna worry about that right now. Okay, so really this is let new nodes be self.nodes dot into iter dot map label node match relabeling dot get label some new label, then new label node, none, then label node. Collect, and then let new trees be self.nodes into iter. We're gonna have to clone this. That's the whole idea. Oops. Same thing here. Map, and this is essentially identical. Label trees, and it's just this. Tree. Trees. Tree. And I think this is called node trees. Okay. And self new nodes, self dot left parens dot clone self dot right parens dot clone new trees. What went wrong here? Match. Collect. Okay, that's super easy. Expected reference, sure. I anticipated that. And expected reference. Because new label is, oh, wait, this is wrong. Some, no, that's right. Okay, but new label has a value which we don't want it to have. Hang on, why is this a reference? This is found to be of type. Am I crazy? Shouldn't this be returning get value? Relabeling. Oh, it's a hash set. Right. I don't know why it's not a hash map. I assume I figured that out in the past, though, and this was the better way to do it, so I'm going to not worry about it. Maybe it's not one-to-one. I don't know. Okay, so in that case, it's a hash set. Why? There must be a reason. There's no way that I just made it a hash map. Or that I didn't start by trying to make it a hash map. But it means I can't just snag it. It's a little weird. Why did I do it like that? Okay. I'm gonna make this a hash map. I assume I'll have to undo this, but I'd rather force myself to do it the right way. Okay, so now this makes sense. This is a reference. Okay. Looking good. Let's go back to transformation and see what else is going on. So no methods found in here. Statement.getNode. And statement.replaceNode. Yeah, so this is interesting. We use these addresses. So SymbolNode address, which basically says, as you chase the tree, like it's a list of indices that tells you which index to pick in the tree. So like the root of the tree is the empty vector, and then the right hand child of the first level is the vector with just a 1 in it, because the first time you looked at any children, you want the 1th child, and then you keep doing that, which is like sort of awkward in the new world. It's like transform at, so this just transforms at the root. But this one is transforming by children, but this is just a test. So we actually only ever transform at a root. Interesting. Okay. So I guess I don't need to implement that. I can just have transform at root. So I could do like this. And then say self.transform at hierarchy statement back, empty back. And then transform at root. So now there's nowhere other than test code where transform at is being used. Okay. What did I just do? Yeah, that is kind of laggy right now because there are so many errors. Okay. So now get node. Oh, okay, so now the point though is that we can just do transform at root instead and comment this whole thing out. comment that out. For the moment. And then this new implementation will be what? It's going to be like this. But this doesn't matter. Replace node. Might matter. So transform at root is just transform. So I don't actually need this. Okay, get evaluates to type. Sure, reasonable thing for me to have here. Let's do it right after get root. I guess we can do it right before get root. Get types. How is this evaluated? Huh? Okay, but now I can do this more easily. Because I can say self.nodes.iter .map node.get type. Or not quite. Label node.get type. .clone. SymbolNode root. Has good evaluates T-type. Okay. See how we're doing. Oh, we're doing well. Well, maybe. We're in a new file. So that's nice. What's the problem here? What's the problem here? Is that in workspace? Mismatch type. So it expects a binary symbol tree, but it's good. So where's maybe statement scope coming from? Extract scopes. Okay, I'm just gonna change this one. Binary symbol tree. Get statement scope. Binary symbol tree. Okay. Going. These are tests. We can just dot into. Same thing. pairs. What's the problem here? Okay. All right, where are we expecting to have issues? Probably in here. Length. Okay. And what do we... if we look at SymbolNode, what do we use for length? Size. We use size, right? That's the point. Okay. So let's go all of this. What is happening? Whoa, no, what is happening? Okay. Yeah. so the point of all these is that we're constructing them as old symbol nodes. So for now, let's just do old symbol node. This is going to be a little annoying to undo at the end of all this. We'll do this as old symbol node. We'll do this as old symbol node. This is old symbol node. I think there's a real question as to whether I should have just gone for the plunge and renamed everything. But too late. We're doing it this way. Okay. What's going on here? So my format, my syntax highlighting is being weird. Like, why is this dot into a different color than this dot into? I don't know why it's doing that. Okay, for now, let's implement toString the easy way. Cast it into a symbol node and then toString it. All right. Okay. Still lots of errors. Why aren't they showing up? Ugh. Oh, there we go. Get symbol. Sure. a string, right? Is this a thing? This is on SymbolNode. Oh, it just checks the root and then it does it directly. Okay. Let's just do self.get root. .get symbol. And then SymbolNode root. Okay. So let's find out now. Fine. Why is this a problem? Returns value because we're returning a reference to a symbol. Yeah. That's fair. That's fair. Root is going to drop out of scope at the end of the function, and get symbol is gonna have returned a reference to it. Fine. Yeah, but now there is no root. And if I say get root, it's not going to work. Right, because now S in here is borrowed. Yeah. It's okay somehow. Reference. Okay, I don't really know why I'm trying to return a reference to this anyway. So let's just not. Self.get root.get symbol. Symbol. This is now on. This is now on SymbolNode. That's fine. And now this one, we won't return a reference. Same thing here. Okay. So now we're immediately hitting some of these. Get root as string, sure. String. get name. Call this has symbol symbol okay. You sure? Didn't I just implement this? There we go. Oh man, this is kind of painful with the very slow IDE. Why not able to find it? This is binary symbol tree. This is why. Huh? Get root, get symbol. Why does it expect symbol? Oh. Fair. Okay, I get it. let's go ahead and commit because we've been doing stuff for a while. Intermediate state fixing lots of binary symbol tree. Bugs and implementations. Okay. And where are we now? Expected symbol found symbol. We will clone. All right. We've been at this for an hour and I'm fading pretty hard, so I think I might call it a stream in a moment. Self.symbol. Into get symbols. That's going to be a really easy one. So this is just going to be self.nodes .iter.map label, which we're not going to need. Node dot get symbol. Okay, so here's my question. How does this not need to be a result? Get symbols. Get symbols in order. So we're just ignoring joins. And pulling the other two types. Okay, so we can probably just filter out joins. What does get symbol do? Yeah, okay, so we can just filter out joins. Didn't I just create this? Hello? Here. Okay, so for now let's just do, well, in order, back, let mute to return be this, dot filter label node not node dot is join, and now we can say node dot get symbol dot expect be filtered out joins, and then to return dot sort to return, and now this is just self dot get symbols in order dot into iter dot collect. Yeah. And parens. Okay. All right, I think let's call it here. Intermediate state, looking through compiler errors. All right, awesome. Thanks for watching. Sorry, I know this is a little bit tedious. Just going through a bunch of compiler errors, but here we are. Got to do that sometimes. Hope everybody's having a good day. Take care.